Hello guys, so we are back again, and in this session we are going to continue with the type 4 which we have started earlier, which was the polynomial type. Now we are going to continue from where we have left. We have completed 3 questions in our previous session. Now we are going to continue with the fourth session, with the fourth problem. So our main intention is to make you understand the chapters properly. So for that, if you want, we bring the complete engineering mathematics, okay, which includes gate mathematics also. The lectures which I make are so accurate that you can easily get the 13 marks which are means for mathematics in gate. You can easily secure them if you follow these lectures. Okay, the structure pattern which we follow, okay, for each and every type of question in each chapter is exact. We don't change it, we just change the how we need to approach a little bit, but the exact pattern is almost same, so that you don't need to get stuck, okay, that we have to follow different pattern like here in type 3 or type 1 or type 0, okay, type 1, type 2, type 3. And in the previous chapter also you have seen continuously that whenever I taught you anything, I just followed that pattern till that type was concerned. We used to do the same thing even though there were 12 questions on that type, even though there were only 6 questions, but our main intention was to not make things complicated by writing different step, okay, for different problems. So our intention is that we do the same step only, so that you get some fixed step in your mind, okay. So our purpose is to bring quality content to you. Now with this, let's begin with the session. Now the question which we are going to take in this session is fourth question, which is this: d power 4 plus 4d square into y equal to x square plus 1. So you know we are going to write the auxiliary equation is, just replace in f of d, replace d by m. The moment you do that, you can take m square. Here m square plus 4 will be left common, giving you m equals to 0, m equals to 0, m equals to iota 2, m equals to minus iota 2. So we are getting these things. Now complementary function, so you can say roots of the auxiliary equation m equals to 0 are real and equal, while m equals to 2 plus minus 2 iota are complex conjugate. After this you can just get the complementary function, which will be nothing but c1 plus c2x, since two roots are same, e to the power 0x, plus c3 e to the power 0x, real part is 0, c3 cos 2x plus c4 sin 2x. This is our complementary function. Particular integral, we will do the same thing, 1 by d power 4 plus 4d square into x square plus 1. Take the lowest power outside. What is the lowest power? Now children do the same mistake again and again. Whatever coefficient attached with the lowest power, you have to take that also common. They take only the d square common. Please don't do that, otherwise 1 will not be created, and we want to create 1 upon 1 plus x or 1 upon 1 minus x format. The moment you do this, you are going to get something like 1 plus d square by 4 format, because when you would take d square common here, this d power 4 will cancel out and will become d square, and here x square plus 1. Now let's use the Maclaurin series and expand this, and here just keep this as it is. The moment you expand this, 1 minus d square by 4, and do you think we need to proceed forward, because the highest power in this polynomial is 2, so we will stop there only, and here we will multiply this with this x square plus 1. The moment you do that, your job is done. Now you can get your answer easily. 1 by 4d square, here multiply x square plus 1 Here d square by 4 will be as it is, x square plus 1, and you are done. After this, just differentiate the things and see what you are getting. X square plus 1 will be here. Just twice differentiate this, which will leave this here 2. If we are getting here 2, 2 will cancel out with this 4, and here 1 by 4 will be left. 1 by 2. So we are left with this, and here 1 by 4 d square bracket x square plus 1 by 2 will be left. So this is our particular integral. Now we can write the, but before writing we know that 1 by d is what? Differential integral operator. So what we are going to do, we are going to twice integrate this function and try to see what we are getting. So if we integrate it once, what we are left with, x cube by 3 plus 1 by 2 in the numerator x. Dx will be attached because here integration will again occur. So we are going to left with 1 by 4 d power 4, 3 into 4 will be multiplied, which will become 12, and x square by 4 into plus c or whatever. So we are getting this as our particular integral. Now you can write the general solution, which is combination of complementary function plus particular integral, which will give you your final answer, c1 plus c2 x e to the power 0x plus e to the power 0x bracket c3 cos 2x plus c4 sin 2x plus particular integral 1 by 4 bracket x power 4 by 12 x square by 4. So we are getting this thing. Now let's move on to the next question. The next question which we are going to take is this one. The question says d cube plus d square minus d square into y plus 1 plus x square is what? Its solution. First try to get the auxiliary equation, is nothing but m cube minus m square equals to 0. The moment you get this, after this what you have to do, you have to solve this. The moment you solve this, you are going to get something like m square you will take common, m minus 1 will be left, equal to 0, giving you m equal to 0, m equal to 0 twice, and m equals to 1 once. So roots of the auxiliary equation are m equals to 0, 0 and 1. So roots of the equation are real and equal. Now complementary function you can get here, c1 plus c2 x e to the power 0x, since these two roots are same, c3 e to the power x. Particular integral will be nothing but 1 by d cube minus d square into 1 plus x cube. Here children do the same mistake, don't take d square only outside, take minus d square outside. If you take minus d square outside, then only you will get 1 minus here d will be there. So then only this we will get, and 1 plus x square cube will be there. Now you can do the binomial, your Maclaurin expansion of this. So if you do this, what you are going to get is 1 plus d plus d square, and it will go on. Now what we require d cube, because here d cube is present in the polynomial. Now multiply the polynomial inside. If you multiply, 1 plus x cube will be here, d into 1 plus x cube will be here, d square into 1 plus x cube will be here, and d cube into 1 plus x cube will be here, and we are done. After this, if we differentiate 1 by minus d square, 1 plus x cube will be here, here 3x square will be there, here if we differentiate for the 6x, and if we differentiate it for the 6 will be there. We are going to left with, if we collect the things which are similar and which are different, here 6 plus 1 will become 7 and rest will be as it is, then we will integrate. So minus 1 by d square, we will try to integrate them after x cube plus 3x square plus 6x plus 7. So let's integrate this. First we will take 1d, and if we do the integration, x raised to 4 by 4, 3 by 3 will get cancelled out, this 3 will get cancelled out. Here if we do, this will become 3x square plus 7x. Here dx will be there. After this, if we do again the integration, it will be 5x power 5. 5 into 4 will become 20, x power 4 by 4, x cube, and this 3 will get cancelled out, and 7x square by 2. So this is our answer. So after doing the twice integration, you will get this as your answer. So this is a particular integral, and we know general solution is combination of complementary function plus particular integral. If you write the things, c2x e to the power 0x plus c3 e to the power x, now plus this minus x power 5 by 20 plus x power 4 by 4 x power cube plus 7 by 2 x square. So this is our answer. Hope you have understand each and everything. Now let's move on to the next question. The next question which we are going to take is the sixth question. The question is d cube minus 2d plus 4 into y equals to 3x square minus 5x plus 2. So this problem is similar to that only. Here you will take the lowest power, which is 4, because d power 0 is nothing but 1. Now first we will do the same thing. Auxiliary equation is m cube minus 2m plus 4 equal to 0. If we try to solve them, one root you will do by 8 and trial, and if you simplify them you will get this m square minus 2m plus 2 equal to 0. So you are getting finally as m equals to minus 2 and m equals to plus minus iota as the m roots. Now the roots of the auxiliary equation m equals to minus 2 is real and distinct, while m equals to 1 plus minus iota are complex conjugate. Now you can get complementary function, which is c1 e to the power minus 2x plus e to the power x bracket c2 cos x plus c3 sin x. After this you can get particular integral, which will be nothing but 1 by d cube minus 2d plus 4 into this polynomial 3x square minus 5x plus 2. After doing this, you have to take the lowest power outside. If you take the lowest power outside, you will be left with 1 plus d cube minus 2d by 4. Here 3x square minus 5x plus 2 will be there. Do the Maclaurin expansion. If you do the Maclaurin expansion, 1 minus d cube minus 2d by 4, and here plus d cube minus 2d by 4 the whole square, and you know rest is not useful. 3x square minus 5x plus 2. Now we know what things we are required. From here we know here d cube is there and we don't require that, so we are going to keep what, 2d by 4 only. So 1 plus 2d by 4. From here we know only this term will come 2d, so 2d square is what, 4d square. 4d square by 16 will again cancel out, and we are going to left with this will be what, 4, and this will be 16, so it will be again d square by 6, d square by 4 only. So we are going to get plus d square by it will be, here it was okay, in the middle it will be negative d square by 4. So we are getting this thing. Now we have to multiply 3x square minus 5x plus 2 inside to get the answer. After this, what we are going to do, we are going to multiply the polynomial inside, which will give us our final answer, d into 3x square minus 5x plus 2 plus d square by 4 into 3x square minus 5x plus 2. So if we try to simplify them, 1 by 4 bracket 3x square minus 5x plus 2 plus this will become d by 2, and if you differentiate this, will be 6x minus 5, and here if we do the twice differentiation, this will be 6 only, so 6 by 4. If we do the further simplification, this will be what, minus 5 by 2. Minus 5 by 2 will be left here, and finally what we are going to get, minus 5 by 2 here, 3 by 2. So which if we simplify, minus 5 by 2 plus 3 by 2, if we add on, it will become 2, which will become 1 in the finally, and when minus 1 will add on with this, it will become 1. So our final answer will be nothing but 3x square minus 2x plus 1. So this is our final answer, which is particular integral. After this, what we are going to do, we are going to get the general solution, which will be combination of complementary function plus particular integral, which you can write as c1 e to the power minus 2x plus e to the power x bracket c2 cos x plus c3 sin x. After writing this, you have to write the particular integral 1 by 4 bracket 3x square minus 5x plus 2 plus here 1 plus minus, I wrote the starting step, 3x square minus 2x plus 1. So this is our required answer. Hope you have understand each and every step. The whole of the step is same only. You just need to take a little bit care and then you will get the answer. So in this session we are going to do these 3 problems only. In the next session we are going to take more problems. Till then, practice these problems and see you in the next session. Okay, bye.